In an open delta 120/240 volt service, it is permissible to downsize the high leg service conductors and install a fuse switch with a reduced fuse in the B phase. This practice is addressed by the National Electrical Code, specifically section 240.15b3. This section outlines the conditions under which such downsizing is permitted, primarily when dealing with open delta or delta-delta transformer configurations supplying a 3-wire, single-phase load. The core requirement stipulated in NEC 240.15b3 is that the service conductors must have an ampacity that is not less than 83.33% of the ampacity of the fuses or circuit breakers used in the service switch or service overcurrent device. Alternatively, the service conductors must have an ampacity that is not less than 100% of the ampacity of the transformer winding protected by the overcurrent device. In this specific scenario of downsizing the high leg conductor and using a reduced fuse in the B phase, the reduced fuse serves a crucial function. It is designed to protect the smaller high leg conductor from overloads. The fuse's lower ampacity rating ensures that the conductor is not subjected to current levels exceeding its capacity, thereby preventing overheating and potential damage to the conductor insulation, or even a fire. The other two service conductors in the system, which are not downsized, are protected by the overcurrent device in the main service switch. This overcurrent device, typically a circuit breaker or a set of fuses, is sized to protect these conductors based on their ampacity ratings. It is important to ensure that the overcurrent device is properly coordinated with the conductors it is protecting to provide adequate protection against both overload and short-circuit conditions. The application of NEC 240.15b3 requires a careful consideration of several factors, including the transformer's characteristics, the load requirements, and the ampacity ratings of the conductors and overcurrent devices. It is crucial to accurately determine the transformer's capacity and the expected load to ensure that the service conductors are adequately sized to handle the anticipated current flow. Overcurrent protection devices must be correctly selected and sized to provide protection for the conductors. Improper sizing of the fuses or circuit breakers can lead to inadequate protection, potentially resulting in conductor damage or even electrical hazards. The high leg, also known as the stinger leg or wild leg, has a higher voltage to ground compared to the other phase conductors. In a 120/240 volt open delta system, the voltage from the high leg to the neutral conductor is approximately 208 volts. This higher voltage must be considered when selecting electrical equipment for connection to the high leg. Certain types of equipment, such as lighting and appliances, may not be suitable for connection to the high leg due to its higher voltage. Before downsizing the high leg service conductor, it is essential to conduct a thorough load calculation to determine the minimum required ampacity of the conductor. This load calculation should take into account all connected loads, including lighting, appliances, and any other electrical equipment served by the system. The calculated load must not exceed the ampacity of the downsized conductor. The NEC provides specific requirements for conductor ampacity based on the type of conductor, its insulation rating, and the ambient temperature in which it is installed. It is crucial to consult the appropriate NEC tables to determine the correct ampacity for the selected conductor. When installing a fuse switch with a reduced fuse in the B phase, it is important to ensure that the switch is properly rated for the voltage and current requirements of the system. The switch must be capable of safely interrupting the maximum available fault current at its terminals. The fuse must be of the correct type and size for the switch. The fuse's ampacity rating must be carefully selected to protect the downsized conductor without causing nuisance tripping. Proper grounding and bonding are essential for the safe operation of any electrical system, including an open delta 120/240 volt service. The grounding system must be installed in accordance with NEC requirements to provide a low impedance path for fault current to return to the source. This low impedance path helps to ensure that overcurrent protection devices operate quickly and effectively to clear faults. Bonding refers to the connection of all non-current carrying metal parts of the electrical system to the grounding system. This bonding helps to minimize voltage differences between metal parts, reducing the risk of electric shock. The NEC provides specific requirements for grounding electrode systems, grounding conductors, and bonding conductors. It is important to follow these requirements carefully to ensure a safe and reliable electrical system. All electrical work must be performed by qualified personnel who are familiar with the NEC and local electrical codes. Improper electrical installations can be dangerous and may violate local regulations. A permit may be required for electrical work, and inspections may be conducted to ensure compliance with applicable codes. The open delta configuration offers certain advantages and disadvantages compared to other transformer configurations, such as the delta-delta and Y-Y configurations. One advantage of the open delta configuration is its lower initial cost, as it requires only 2 transformers instead of 3. However, the open delta configuration has a lower capacity than a fully rated delta-delta configuration. The open delta configuration is often used in situations where the load is relatively small or where future load growth is not anticipated. It is also used in some emergency power systems. The NEC provides specific requirements for the installation and maintenance of transformers. These requirements cover topics such as transformer location, ventilation, overcurrent protection, and grounding. It is important to follow these requirements to ensure the safe and reliable operation of transformers. Regular maintenance is essential for ensuring the long-term reliability of an open delta 120/240 volt service. This maintenance should include periodic inspections of the conductors, overcurrent protection devices, grounding system, and transformers. Any damaged or deteriorated component should be replaced promptly. It is also important to ensure that the connections are tight and free of corrosion. Loose connections can cause overheating and potential electrical hazards. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and industry practices. It is essential for all electrical professionals to stay up to date on the latest version of the NEC. Local electrical codes may also apply in addition to the NEC. These local codes may have more stringent requirements than the NEC. It is important to consult with local authorities to determine the applicable electrical codes. When working with electrical systems, it is essential to follow safe work practices. These practices include wearing appropriate personal protective equipment such as safety glasses and gloves. It is also important to energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. If it is not possible to de-energize the circuit, use insulated tools and equipment. Never work on electrical systems when you are tired or under the influence of drugs or alcohol. Electrical safety is everyone's responsibility. By following safe work practices and complying with applicable electrical codes, it is possible to prevent electrical accidents and injuries. Proper documentation is essential for any electrical installation. This documentation should include a wiring diagram, a load calculation, and a list of all components used in the system. The documentation should be kept in a safe place and should be readily available for future reference. The wiring diagram should show the location of all conductors, overcurrent protection devices, grounding system components, and transformers. The load calculation should show the total connected load and the calculated demand load. The list of components should include the manufacturer, model number, and rating of each component. This documentation can be helpful for troubleshooting problems and for making future modifications to the system. The information provided here is for general guidance only and should not be considered a substitute for professional advice. If you have specific questions about the application of the NEC or local electrical codes, consult with a qualified electrical professional. Working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock. If you are not comfortable working with electricity, hire a qualified electrical professional to do the work for you. Remember to always prioritize safety when working with electrical systems. By following safe work practices and complying with applicable electrical codes, you can ensure a safe and reliable electrical installation. Always double-check your work to ensure that everything is properly connected and installed. A thorough inspection can help to identify potential problems before they cause a safety hazard. If you are unsure about anything, consult with a qualified electrical professional. The safe and reliable operation of electrical systems depends on the knowledge and expertise of qualified electrical professionals.